All right, so now you've gone through the intro part. Welcome to the first course. This is the Cyber Threat Intelligence Researcher Certification. This certification is for everybody who wants to get more into information security roles, and especially your threat intelligence roles as a part of the cybersecurity workforce. So I will try to make this certificate as easy when it comes down to explaining as much concepts, and of course we will go into different phases when it comes to certificate. We will have some labs, and I will also make you more familiar with some new concepts and some concepts that you already would be familiar with in the past. Okay? All right, so let's roll on. To start with, the full certificate, I've divided it into many courses, and this particular course, which is the first course, it's called Different Phases of Threat Intelligence. So I have divided this into smaller sections or smaller classes, around 7 to 8 classes, so that you can easily understand and learn on the go or consume whatever I am teaching you, and try to also make some real-time use of that also. As we go into the courses a little bit more deep, I would say you would need to follow a lot of labs and also to do your own research work, ethically, of course. Remember that. All right. So moving on. So what is cyber threat intelligence? So that is the question, which comes to everybody's mind. Of course, you have gone through certain sections, and you know that there is ethical hacking, there is ATP. Like, what is threat intelligence? Is it like part of reverse engineering? Actually, it is not, right? So when we talk about threat intelligence or cyber threat intelligence, we have to understand that the concept goes much beyond or deep from a list of IP addresses with poor reputation, I would say, or hashes which are suspected of bad files. So it is beyond that. So threat intelligence is not just looking into those IP addresses, those different hashes with like some bad malware or EXEs or DLLs and so forth, right? So CTI is evidence-based knowledge of either an emerging or an existing threat, all right, and that can be used. So this knowledge you gather while studying a threat which is already there or something which is new, okay, and this knowledge then you take with you to make some informed decisions, and let your management know also, and you as a member of the threat intelligence team should also know how to respond to these different decisions, different threats, threat vectors which you get faced with. So CTI encompasses that, and also CTI provides more than just the specific bits or bytes of that threat, I would say. It also provides the context around it, who the attackers are, where they came from, things of that sort, right? And you will come to know a few concepts around like how to identify the indicators of the attack, how to see the indicators of the compromise, what are those different indicators. You'll come to know, and you'll be aware of those when you're going a little bit deeper into different concepts within the class. Of course, and potentially even the identity and the motivation of the attacker. So I'll teach you how you can, identity, yes, you can dig around and find it, but motivation piece is basically putting all the puzzle together, right? And in the security industry, in the security field, you will hear these terms a lot. So security practitioners and security technology itself. By technology, I mean your softwares which you have deployed in your organization. So they can use CTI to better protect against threats, or even to detect the existence of threats within a trusted environment, I would say. So exceptions are high that CTI will significantly improve system or a network security when it is integrated with the organization's infrastructure and its operations, I would say. So threat intelligence will not improve anything unless you're using it correctly, you are studying the knowledge, taking it back, and analyzing it to a point, right? So by using CTI, security teams usually look not to stop each attack as it happens, but to also get a better sense of who's attacking. What are the different methods, what are different techniques, What are the different targets, you know? So all that you come to understand and know when you are looking into different parts of CTI. So cyber threat intelligence is a key to gaining that level of understanding about a particular cyber threat or a particular cyber attack. All right. Let me actually give you a little example so you understand this and how companies have used it in the past, right? So if you look at this slide, this is a good example where Microsoft actually teamed up with FBI to take down a botnet, which is a very active botnet, and it was called the Game Over Zeus botnet, right? So those of you who are in the security field must have heard about Zeus botnet, and this was the game over where a company, a big profile company like Microsoft, went out, and their role was that they'll take like technical actions and conducting and analyzing also this peer-to-peer network, which was basically the Game Over Zeus botnet, right? Also through this monitoring was happening through an additional feed from, maybe a shadow server was put in place, and Microsoft was actually able to do some augmentation there and have a little bit more visibility into the number of impacted IPs that identify the cyber threat intelligence program, and also identify identify the cyber threat vectors, and also identify what our computers are getting basically hampered by this. So these kind of scenarios happen a lot actually in the security industry. So a lot of companies who have a good practice of cyber threat intelligence programs, and also have good response teams, and they work very closely with ISPs to help the owners of the compromised computers to regain control of their systems. And this is basically, of course, you always have to keep law enforcement into confidence so they know what's going on, and you don't step in the wrong arena, and you're not suspected as one of those bad guys when trying to augment or trying to contain a particular malware. All right. Okay, so now you understand CTI. I've given you an example how companies use CTI and how they can gain trust and then basically loop in FBI to catch these culprits and basically the hackers and the bad guys. All right, so now let's move forward, and I'm going to actually give you a little bit insight into, if you look at this slide, this is the insight into the full threat intelligence techniques which we'll be talking about. Basically 7 techniques, and I'll be going over those techniques in the agenda part this coming forth. All right. So to understand what is CTI and its core process, this is like those 7 steps, and the first one out here is hunting. So I will actually go a little bit into each one of these, and then subsequently I will explain them a little bit more to you, so you understand them, you understand how exactly they fit into the big picture. All right. So coming back, hunting. So before starting any kind of analysis, you need to actually have some samples and some simple knowledge of your software, that what is going on here, right? So you need to make and to develop those skills, you have to hunt for the software online. And hunting is basically, as the word also implies, it is you go out there, you look for different patterns. First you look for the malicious software, then only you can try to do anything with that software. So hunting is the first step, I would say. Then comes your features and behavior and extraction. So once you have gone and done your hunting part, now you have to see what are the features, and these are the static features, mind you, which you need to extract. And same goes with the behavior. So behavior part, when it comes down to feature extraction and behavior, is basically once you have a good idea, when you've done some hunting and you extracted some basic features out of using your feature and extraction phase, then you go and look at the behavior of that particular malware, right? And basically you will you need to know what is going on when it comes down to what does it do when you download it from the internet. Is that malware written to steal or to hide or to launch some other files, or is it opening a backdoor? So those are all like behavior kind of things which a malware would do, or there's, of course, there's much more to it, right? So that is what behavior literally means. Moving forward, clustering and correlation is the next, I would say, step, and which after hunting, after you're done feature and behavior, you need to basically take that and start clustering it into groups. Why? Because these groups, then it'll help you better understand what an attack flow is. So remember, you are a threat intelligence researcher. You have to identify all these different malwares and softwares and any other malicious file which you are studying. You have to identify. You have to identify it piece by piece, feature by feature, and separate them out. All right. Then only you can do a full analysis on that particular malware. Right. So mainly you should know some pieces which you should know around here are what are the threat actor attributes, right? Mainly after you've done your clustering, now threat actor attributes is also a key thing which you should know. So that is like, who is the threat actor, who is the perpetrator, who is behind the whole operation, right? So that is something which everybody wants to know. Your boss will say, hey, where is this attack coming from, and who's attacking us, or who's locked down our file? So that's time you need to wear your researcher hat and then try to like get the right information out. So to identify the threat actor, it is important to know that who is doing it, of course, but then also where is it coming from? Where is the command and control server, if there is any, right? The CNC server, and when is it launching the control to the victim machine? All the different I would say things are part of that, right? Next thing is tracking and taking down. So once you have identified the pieces of it, like these are the different features, this is the behavior, this is how you clustered it, you correlated it. Now you gotta basically track it down to its source, right, and take it down. That is the final step. And taking down again is basically sometimes comes down to you have to physically work with the local law enforcement and even international law enforcement like Europol, or even if they're in other parts of the world, you have to work with them and get the bad guys down. Of course, working with the law enforcement, giving them all the evidence which you have. Next, one thing which I want to make sure is that you understand all the different steps which I'm going through. So these will help you design the full class, which basically is around all these different steps. All right. So now let's look at threat intelligence researcher goals. What are the different goals when it comes down to threat intelligence researcher? All right. So first one is to identify and track threat actors. Well, that's one of the goals. At the end of every research, you should know and you should be able to locate and track that who has basically conducted that attack. You should also be able to help to be proactive instead of reactive, and that's one thing which you should know when coming into the security field, is that you have to be proactive when it comes down to anything. Right from hunting to getting samples to going out of the way and even collaborating with other security engineers and other security I will say researchers online. Even collaborate with reverse engineers to understand a malware better. So those are some things which will which you will come, of course, you will come to know with experience. But those are like very important traits when it comes down. I would say for a threat intelligence researcher, right? Also, broader detection is another thing which you should look at, is by finding more malware from different parts, different segments of the internet, I would say. So another thing is once you know certain traits of a malware, you should have a full picture of the attack. That is super important to make any kind of decisions. So your discoveries, when it comes down to the malware, the pieces, you have to kind of put everything together, work with different teams, even go above and beyond, and involve other companies. Even if it's competition, when it comes down to companies, you'll be surprised how of course if it's a 0-day, everybody wants to protect it and put their stamp on it. But if it's not, then everybody will help you, especially like containing and if they have some certain experience in a different strand or a different I would say copy of that malware which you are fighting against or trying to protect against. All right. And another thing is discovering the insights of malware is key. And for example, if you're connected to, if the malware is what it does, like behavior, when it's usually what happens is some malwares, as soon as they download, they connect to the internet, right? Some malwares, they start extracting files or cleaning and deleting files, or they go for the credentials on the infected machine, the admin credentials, right? So these are some of the behaviors which you should look at when it comes down to an intelligence researcher, especially when you're trying to classify, trying to understand, what traits when you're looking at. And as a threat intelligence researcher, some goals which you should always keep as part of your, I would say, agenda whenever you're looking at something is basically, does it stand out? Is it suspicious? How you should start analyzing it, right? So those are some of the traits which you will build with time as a CTI skill set. And also you should know when you're what you have to do when you're trying to get information about the infiltration, the techniques which you should be using, and of course who is responsible behind the full operation. So you're able to understand the full picture by piecing up all the different parts of the puzzle, right? So all these different malwares which are out there, it could be there's a single person, or there could be a group of people, a gang, so a gang dismantling can happen if you work with, of course, as I said, local authorities, law enforcement, Interpol, Europol, FBI, and so forth, right? So even international organizations always pitch in to help you catch the bad guys, and because they are facing the same kind of threats in their countries also. So good things to remember. Always work with the law enforcement. Always try to build the whole puzzle. Be proactive. All right. Great. So this kind of brings us to the end of class 1, and in class 2, actually, I'll get a little bit more into hunting, which is a good characteristic to start with when it comes down to threat intelligence researcher. All right. Thanks for joining. I'll see you in class 2. Welcome back. This is class 2 of your first course, that is Cyber Threat Intelligence Researcher Certification, and I'm going over different phases when it comes down to cyber threat intelligence. All right, so look at this pretty picture here. So these are all the different phases or techniques, you may say. These are different phases, and I'm going to go over the first one, that is hunting. In the prior class, I did go over all of them one by one, and just to make you familiar with it, so these words don't sound, or whatever I'm explaining doesn't sound too new to you, right? All right. So there's few classes which I want you to pay special attention to, and the first one, that is this one, hunting, is a very, I would say, interesting class for me, and it should be for you also, because this is where everything starts. All right. Okay. Let's move forward. So what is the goal behind hunting? So I want you to understand the goal to start with. Hunting is basically a technique which is used to collect samples from different sources and different threat sources. And in turn, these samples, they help you to start profiling this malicious software, or even the malicious actors behind these softwares. So we need to gather these samples from all these different sources, whichever you can get your hands on, so we can identify all of them, and this all encompasses and is part of hunting. All right. So that's the first part. It's very simple. Just go out there and just gather samples from different sources, different threat sources, and then you try to make sense of it. But hunting is, how do you do that, right? It's not that you're just going on like internet and you just type in something and MD5 hash and it'll start giving you data, right? It's not that simple either, right? That's why we have this class, and I'll explain it to you, and that's why you have to pay special attention on how do we classify these sources and how do you get hold of different information from different places and piece it all together. All right? So let's move forward. So again, now first thing is we look at different sources, and I want you to be familiar with a term which you will keep on hearing, that is VirusTotal. All right? Giving you a little bit background on VirusTotal. The website is virustotal.com. It has been there for over 10 years, I think so now. And it's a web-based tool. And VirusTotal is basically now part of Google. Google thinks so acquired it. It was a free service, and lots of it is free still. You can go in and analyze files. You're enabling, you can do identification of viruses, worms, trojans, all different kind of malicious content. And these all can be detected through, or actually searched through VirusTotal. And the main thing in VirusTotal is it is basically, it kind of works with all the different antivirus engines and website scanners which look out for all these different threats out there, right? So VirusTotal simply acts as an information aggregator, I would say. But it's the only cool one which you would use in your as a threat intelligence researcher a lot, actually. And this aggregated data basically is the output of your different antiviruses, also website scanners, even files and URL analysis tools. So the URL analysis tools are out there, which will basically also go in and tell you which IPs and URLs, how they are. So they all gather this data, and even users go out and contribute data to VirusTotal. That's why it has the back of all these different antiviruses out there, and also users have started submitting data to it. And you can imagine 10 years it's grown very intelligent just because the input of data which it has. And VirusTotal not only tells you whether a given antivirus solution detected a submitted file, but also displays the exact detection label returned by each engine. So it has got that classification that, and I'll show you like how it basically shows that information also in the coming classes or in the coming slides. Also, another thing, a very useful service which VirusTotal offers is the hunting or the intelligence solution from VirusTotal. All right. So this is a service which is a paid service, and what it does is it also lets you, of course, it lets you search everything, and also lets you download samples of those files from their database. So that way you always know what is going on. You can also, while doing these searches, you can apply Yara rules, and we're going to be talking about Yara rules and what they are and how they work. But basically there's some rules which you can run on VirusTotal, and it gives you good information back. And these rules, of course, you can automate a lot of stuff there's an API also involved with VirusTotal, and all this can automatically get emailed to you back itself. So pretty interesting overall VirusTotal tool, and even the paid part of it, it is well worth it. All right, so next thing after VirusTotal is understanding of underground hacking forums. So the underground hacking forums basically lets you go in and search for a lot of these malicious, I would say, code which is lying out there, malicious malware which is out there. And on these forums, people are discussing on these malwares. We can even find, certain downloads of malwares. Though personally, I think it's a little risky business when it comes down to engaging too actively with these forums. So I would pose some caution down there. These underground forums where, I'm not talking about your regular hacker.com forums, and these are like off the radar. These are like part of, a different concept, not your hidden indexed, not your normal indexed websites. These are the ones which you cannot search on your Googles and Bing and other search engines. So be very cautious and very aware of what you do and what you download from there. And I would actually highly recommend not to download anything from these forums. But I wanted to expose these to you, that underground hacking forums is one thing where all this happens. The people are interacting and tracking. And further, when we get into the course, I'll explain to you why you should be cautious and how far you can go when interacting with these kind of forums. All right. Okay. Next up is another interesting concept is deep web. So deep web, the regular web which you know right now is basically you take your IE, Google, or any other popular web browser, and go and search for your sites, your favorite sites, right? But deep web usually cannot be searched like that. These are the hidden sites, and normally they are being accessed by Tor, and Tor is not only another way to access internet, but it is a very secure way in which it literally goes in and tries to search or does a good search on the non-indexed files, which are still discoverable and which are not being accessed by normal search engines. All right. And Tor browser is there, so it's like Onion browser, that's what it's also called. So this browser is good to go in, and it's basically you have no, it hides you also, it goes behind a proxy, it sets you up in such a way that your location is also scrambled a little bit. If you're sitting in US, it'll show that you're in another part of the world and things of, so that's how, so deep web is your non-indexed and still searchable part of the internet, which I'll explain is huge, and it's actually much bigger than the regular internet, which you all guys know about. All right. There's a lot of malicious activity which happens out there. The hackers, they are setting exploits and malwares. So deep web is not something which you just go and just download Tor and start playing with. No. And that's why I'm kind of putting out all the red flags to you, and you will understand why later on down in the course also. But I don't want you to have even a little bit knowledge, get introduced to a word called deep web, and download Tor browser and start, searching for malware and stuff. You could get in trouble, so don't do that. But do have the concept, understand it, what it is first. All right. So next is incident response engagement. How does that work? So as a security analyst, you will be working for many companies, even for consultancy services, firms, in-state, out-state, in the country, even remotely from different countries, right? So it is very common that you'll be looking through different systems, mainly those systems that have been compromised, because sometimes you're part of a red team and they get you down there to analyze what's going on, or even to perform some analysis beforehand, right? So you may need to grab a lot of information, for sure, and you could grab these from these compromised systems also, and this could be you've been guided or told to get some DLL files or grab some EXEs, executables, and you don't know, and they also don't know what it is, right? So having to analyze these files, you have to send them back to your team sometimes, and most times you try to do it first, you try to contain it and then send it back. Once they analyze it, they send you information about the pieces of the malware, and This is also another way of hunting actually. So where you can do some incident responsive engagements are there, and then you basically go in, grab some information, send it back for analysis, get back the information which your core team or center has provided to you, and then you can basically go and do some kind of analysis on top of it. So basically, it kind of is hunting, but not. But definitely, it's another way to gather your malicious samples and to get more feedback and information around it and contain it. Next is another concept which you must have already heard, honeypots. So we're still talking about hunting, guys. Those of you who are joining us right now or just want to give some context. So hunting, and we're just going over different ways in which you can do hunting. All right. So honeypots, a lot of you have heard about it, and traditionally it was actually is basically you set up different servers, and then you make those available. You basically take some servers or environment and you expose it on the internet. You open some ports on it, right? It's like a honeypot, right? So where the honeybee comes or any other bee comes and just sticks to it. So you're kind of creating that environment to attract the bad guys. Very simple, right? And once you open these ports, and these bad guys, they will come in, and you will be surprised how fast these guys can reach you or your environment which you just set up, because there are these automated tasks which a lot of these bad guys out there or these hackers are put in place, or even hacking organizations are put in place, and they look for specific IP addresses, right, and ports. And once they see a port open, then they start entering that. So that's how a honeypot is set up, and that's what a honeypot is, right? So you're basically attracting all your hackers and attackers, right? And once they get in, then you start gathering samples of the infection. Maybe it is from the port, maybe it is from a sample which got downloaded. So because since it's in the contained environment, you kind of control it, right? So you have to make sure contained environment, and then once they get there, then your hunting starts. You start hunting for all the different ways, all the different samples which you can get from the attackers and the hackers. All right. Okay. So next one is OSINT, and this is your open source intelligence, OSINT. So open source intelligence, basically, it is a well-known term, as you all know. This is basically going on your internet, on Google, on your popular search engine, it could be Bing, anything, right? And going and searching and hunting for different parts of information. So that is another key piece, where you go in and see what is the publicly available information for this particular source. So that's again a different act of hunting, and this is called the OSINT, and it's basically stands for Open Source Intelligence Gathering. All right. So this actually brings us to end of class 2, which was basically explaining the phases, that is hunting in this case, at a very high level. I'll have another full class on hunting. You're not done with hunting, and in that I'll go a little bit more deeper into VirusTotal, into all these different OSINT and deep web and different techniques which I talked about. All right. Well, thanks for joining. I'll see you in the next class and give you a little bit overview about the next phase, that is feature extraction. Thanks for joining. So as a threat intelligence researcher, you need to know all the different phases when it comes down to your threat intelligence CTI, right? So today I'm going to be talking about feature extraction, which is actually the second phase or second part when it comes down to different techniques for your threat intelligence gathering. So far we have gone over the first part, that was hunting, right? And we talked about malicious binaries, the different files, how you kind of go and find them. So next is basically threat intelligence and when it comes down to your feature extraction. So in this phase, you will learn what to do with those samples which you've gone in and fetched or analyzed or downloaded or got access to. All right. So first things first. As far as you know that the binaries are there with you for now. You've done your hunting part. So next is, as I mentioned, is threat intelligence. And as the words the specified, threat intelligence is basically a part of your full phase. That is your different 7 phases, and hunting is part of it, and even feature extraction, which we're going to talk about right now, right? So in this phase, you will learn what to do with all the samples you collected, how to further analyze them, all right? So is this game on? Now you've got access to those samples, right? So the goal of feature extraction is to identify unique static features in a binary. Remember static, this word. So it basically takes feature extraction is to identify the unique and static features in a binary that will further help you classify them into specific malicious groups, all right? And that is the main goal behind feature extraction, all right? So what does this literally translate to? Well, as a security analyst and a threat intelligence investigator, your goal is to get static features. Static features like for that you don't have to run any piece of code. These are part of your binary, right? And then you group them into different buckets. And this is the best way to detect what features belong and to which specific malware group, right? So then you identify which malware groups are involved in that particular threat, for that matter. All right. So first thing is when you talk about feature extraction is timestamps. You look at timestamps for a particular binary or for a particular file. So mostly all your Windows binaries have timestamps, and which actually carry a time information, which is a very important piece of information. Why is it important? So with timestamps, you can get when the binary was compiled, when the binary was created. It could be that time it got compiled, right? And it could be compiled in say 2008. So now you know that this threat, this malware, this piece of software which is malicious, which is sitting on your computer, is from 2008. That kind of helps you identify and relate it to a group of those malicious threat actors which were part of that particular time, right? And that is why timestamp is very important. So normally attackers, they don't change the timestamp. You can easily change the timestamp also, but a lot of times it gets copied over from here and there, so they don't pay that much attention to the timestamp, right? But you being a security expert and intelligence threat researcher, you need to look at the timestamp and always remember it. And the specific features which are part of the timestamp, this is like a static part of it, as I said, and you have to basically grab these malwares without running or executing it. That's why we call it static. Also, there are other things which you need to know when you look at timestamp. As I said, you can identify, of course, the time period, how long it's been there, but also what different gangs or what different affiliation, association it could be running to and it belongs to. All right. So one more thing, as a researcher, you should know, and it's a good thing to know, is how do you specify when you see a binary? How do you specify the timestamps for it and the extraction part? How do you make sure you're doing it safely, right? So that is one thing which you need to understand, and you have to learn safe techniques around it. And this is something which again I'll get you introduced in the next course also. But that is something which you'll come to know by experience also, because every malware has to be dealt differently. All right. So Next is your digital certificates. Digital certificates is also another important thing. A lot of attackers, hackers, they use digital certificates to bypass your basic rules. And in some companies, the digital certificates help you, of course, validate that, oh, well, this is a very trusted company, and so suppose the certificate is from Microsoft, right? So now, when your scanner sees it, it'll say, hey, this software is digitally signed by Microsoft because it has a digital certificate. But Microsoft has not signed those binary files, and if they have, then there's a trust. If they have not, then it is they're using a malicious name, but then the certificate could be old. It could be something, which is done, a self-signed certificate is there. So all of those things have to be, dealt with and cared for. And users always trust binaries which are from a company. You can be verified by even analyzing a digital certificate for those drivers. So using it, we know that the source is trusted or legitimate. And there are other ways to go around it, right? So how do bad guys do it? Commonly referred to as malware authors. They also use digital certificates, as I just mentioned. They steal them, they self-create them, they use old certificates, they try to do each and every wrong thing when it comes down to certificates. And mind you, certificates can be created on any information server by simply generating a self-signed certificate, right? And then you can name it Microsoft, Google, whatever you want to, But then once you look closer into the certificate, it will fail. But then a lot of the malicious authors, they take onto these techniques, right? So all these tricks, believe it or not, they are very successful. They fool a lot of bigger companies, bigger softwares out there. Even most of the software, they don't detect it when it comes down to these tactics of digital certificates and wrongly signed malware. All right, so next one is EXIF metadata. So what is EXIF metadata? It basically is all about your metadata from different files, and it can be your executables, EXEs, it can be your DLLs, it could be any file, Word, PDF, different files, and all of them carry some kind of metadata. So what is metadata? Most of you should know. It is basically that granular data which tells you a bit more about the file. Author's metadata. It helps you give some more information when it was created, saved, different properties, So those are part of the metadata, And it can also help in your RTF exploits, the use of author name, actually. So another good example here is the use of language. So in a lot of the cases, we overlook that, right? So what does language got to do with the malware? I mean, if it's written in hey, English versus English UK versus English, how does it matter if it's written Russian and Chinese? See, I got your attention now, right? So if it's Russian and Chinese, we can see where the originator was. And same way, you can go into different images, Word documents, and get those features, different features to extract where the malicious malwares are coming from. What language is associated with the different, MIME types, or even if there's a message, Outlook message or something. So it'll tell you all that different information, and that will help you start profiling your malicious samples. That's what we're trying to do as a threat intelligence researcher, right? Always remember that. We are trying to profile. As deep you profile, the better hunting techniques you use, the better you are when it comes down to succeeding with your end result, and that is finding and getting the culprits out. Okay. So next is let's talk about import hash tables. So let me first explain a little bit about how this works. You should be aware that every single EXE executable has an import table associated with it. So what is an import table? Well, it is at a very high level. It is basically all the different DLLs which are used inside that binary, and those are all listed together. And these all are, they have their own counts, how many are there, what all DLLs, what specific order they are in. So all of that basically is part of your import, for your import hash table. And this import hash table is unique for each binary, and it doesn't change because the files are always the same. It will only change if you have changed those files, the order, or written some extra code and recompiled it. So I would say it's not a kind of a silver bullet or anything like that, but it is a good technique. And imphash import tables are, you should understand what they are, import table hash, and then you should know how to read it, or if not read it, you should know how to analyze it. And in the next course, I'll tell you a little bit more, and so you have a good grasp and understanding about imphash, which is also import table hash. All right. Another thing is your SSDeep. Now, SSDeep is a concept which is also known as your fuzzy hash. It is basically when you're able to extract sequences of bytes in the same order from the binary. And this also specifies sequences of bytes are going to be used in that binary, in the order it is detected in the sample, or that can be similar to that, as I said. So SSDeep, you have to look to the binary very closely. And there are other things, which can be extracted, features that which could also clarify or classify your binaries in this case also. So moving forward, you have strings, which is also another thing which helps you classify how you do your feature extraction. So basically, you have to get simple human readable strings from binaries or any document that those strings are. Sometimes you can read them from maybe from your command and control center or the IP which the command and control center is using, right, or your CNC. So all those are malicious servers from the attacker. So you sometimes they can also have mutex. Sometimes also called mutant. So mutex is also specific name assigned by a malware author to a binary, so that they can avoid detection from when they are part of the infected machines. And this is what you need to know, that from strings, what are you trying to read? You're trying to read the control and command center IPs, the mutex. You can also have a pretty good idea, what is happening, and if you're doing continuous analysis and find more evidence of the different things which have been performed down there. So PDB and custom control messages is also two other things which you should know when it comes down to string. So PDB path is basically your paths which are a file or directory path when you are compiling a binary. It could be, for example, the PDP path. A good example would be, say, I compiled a binary. It'll be in a Windows machine. It'll say C colon Bali, that's the username, slash software, Visual Studio or something, slash my project and file. So now from this PDP path, I can, if I read it correctly through the strings, I can basically identify that, okay, the username could be Bali or any other username which is given. So there is a lot of intelligence which you can extract from there. And of course, if there are any custom messages which are embedded inside the code, inside the attackers, specifically some error messages which come up and what language they are in, that's also important, So all these things, they help you basically get a good idea about the different parts of your malware, and these are actually part of feature extraction. All right, it's pretty interesting. I hope you're enjoying the same way as I am, right? So in the next class, we'll be talking about another part of feature extraction, and that is behavior extraction. All right, so stay tuned, and I'll see you in the next class. Bye. Hi everybody, welcome back. So this is the Cyber Threat Intelligence course, and we have covered a few of its features, like feature extraction, hunting. Now we're going to talk about behavior extraction. So this is a dynamic way of collecting information. All right, so let's dive in. As you can see in this particular slide, This is the third particular technique which I would say, which you would need as a threat intelligence researcher to go in and get evidence for a particular malware, or if you have detected a particular cyber attack, or if you are being tasked to contain and to research on something which your team is working on. All right. So as far you've learned about hunting, right? And we've gone through different samples. We have also extracted the features statically, right? The static feature extraction which we did. And these two are definitely, they help in your classification, and also they help in specific grouping of behaviors and so forth, right? So now we also want to see how we can segregate these groups more further. And that's why these techniques, which I'm teaching you, they basically take your basic, understanding of a particular malware. You kind of, first you do your hunting phase. You first see what strain of malware is that, right? The next comes you start classifying that into different groups, categories, and sometimes these could be based on static properties also, right? Like the language, from where the originator was, and so forth. And then after that, you look at other specific classifications, like your clustering of them, and then segregation part, right? All right. So now, what is the main goal of behavior extraction? So first, let's look into that. So mainly, behavior extraction helps you identify unique dynamic features in a set of binaries or in a binary, and this in turn helps you to classify them into specific malicious groups. Just mind you, like we were still trying to identify, trying to better categorize, better segregate, better analyze our malware, right? And so behavior extraction works on the dynamic aspect of it. So that is the main goal behind behavior extraction. All right. Okay. So now, what are the different ways which you can see, or which you need to know when working with behavior extraction? Like different features, I would say, of behavior extraction which you should be familiar with, right? To start with, behavior extraction's first feature to be known as normal detection. Happens like how do you normally detect, and when does it happen, right? And this normal detection can happen by running a sample in a sandbox environment, which is like a contained environment where you can learn about certain behavioral properties of a malware, right? And also to all the malicious software, however you kind of you set up your sandbox in such a way that it does not penetrate within your network, right? And you basically see how these features and how you can extract those features, especially when the software when the malicious software is getting implemented, right? So as a threat intelligence researcher, you don't need to know reverse engineering for that matter. Basically, you just need to know all those different techniques to gather information in order to better cluster or better group them, right? And once you can make these clusters, you can you can understand different behaviors also, right? But if you have access to a reverse engineer and at some time in your as a threat intelligence researcher, you think that you do need help of a reverser or a reverse engineer, you go for it and and take their help. But mostly I'll tell that you would not need it if you are properly ordering and clustering your malwares, right? And so you can also get behaviors not only by running a sample, because normally a sandbox is going to tell you if it detects an external API, right? So when you run a sample in your sandbox environment, you see all these calls going over the network, right? So okay, an API call got made, and what part of the API has been called, and from where it is calling the API, and is this what are different parts of malware being used, things of that sort. So you come to know all of these features. You come to know, and I'll discuss these in the coming classes also a little bit more into detail. But this gives you a good understanding, like how running a sample in a sandbox can help you, right? Okay, so another one or another way of behavior extraction is basically looking at your memory dumps, and these are your system memory dumps where this malicious piece of software is being executed, right? Mostly what happens is the malware will decrypt in memory only. So that means it'll, so if you look at, if you start looking at the memory dumps, you then get to know about the certain qualities of a malware, right? For example, the RATs, the remote administrator tools, they have a very common feature, and they have a configuration file which, however, normally gets decrypted in the memory, right? And if you can dump that memory, right, and you can easily then detect what specific strain or type of RAT this is, right, or remote administrator tools is this, right? So RATs are really common because RATs are used to administer and to interact with a backdoor whenever that is implemented or open, right? So which is pretty common, I would say. So behavior extraction, as we know, can happen when you are even capturing malicious events, right? So earlier I walked you through malware in a sandbox. For example, there are other malicious ways where events get fired, not just in a particular sandbox environment, right? These events further can be then classified into specific families, and these are like behavioral families, right? Furthermore, if the malware is creating a file in a suspicious location, like a lot of malwares, when you first execute them, they'll start replicating or creating files, or they will take a particular or download something, and then drop it somewhere. And these kind of software classified malwares are classified as droppers. So a dropper is just going to drop a binary onto the disk, and that's what it does, and then it's done, right? So that's one behavior. Then injecting into a system process is also, you must have heard, right? Sometimes malwares are very conniving. They like to hide behind regular processes in your system, regular threads which are there, part of your regular processes. So they inject themselves, at different stages of a process, right? So this injection which they do, you can go in and you can classify them based on that, what injection has been made by a particular malware, right? Also, some of them, they download an exe, an executable file from the internet, and that's also one common behavior. And these kinds of malwares which download an exe or an executable file, they are called downloaders. And they just go out there. You can go and classify them by looking at malicious IPs, which it basically uses to get the binary and to run it on your system. And it's also one thing that they can do most, I would say, gracefully. That is basically downloading it, and then all these like malicious IP addresses help you classify that, okay, that this downloader is going to this particular IP address. So you remember if the attack flow there are different phases of it, right? And you also see, like, if you can segregate the attack flow, and if you can catch these different items there. Another thing is also keystroke interception. So when you go in and basically you've seen, like, and you must have heard also, there's always these malware which capture your keystrokes, right? So these keystrokes basically there's some kind of Trojans which basically kind of do this job very well. And these Trojans are mostly banking Trojans, right? And I would say it's very common for banking Trojans. So their main goal is to steal information, of whatever you're typing on the keyboard. And that is what their main purpose is. Basically, they capture every keystroke which you make, every, for like basically if you're entering account information, if you're entering sensitive password information, so they just capture all that, right? So other things which you should know is your anti-VM, anti-debugging checks, also your malware, which will check if it is not being debugged or analyzed by a malware researcher, and then you can get all the features also, right? So delay technique is also a very common technique. So a lot of the times, whenever there's a malware written, right, which has a command and control, which has a rat based or something similar, basically malware is going to say that I'm going to probably go and check if I'm being run in a sandbox environment, right? And then it has a inbuilt fail safe for the malware, of course. It just goes and does not perform any activity, just goes silent. So when it finds that it is in a contained environment and it has these certain checks, so a lot of the malwares have evolved, right? And of course, malwares are being written by programmers, hackers, the black hat hackers. They're smart guys, right? So they know the parameters of how a sandbox works, and then malwares basically go and sniff that if I'm being run in a particular contained environment or in a sandbox environment, so they don't execute. And they put a wait timer inside it, so they will wait. And what these sleep timers or sleep calls, are there part of all sandboxes. And then what happens is if a sandbox does not see any activity, it says that, oh well, this is benign and this is not malicious, so forget about it. And then once the sandbox containment is not the malware is not running in a contained environment, then it starts executing itself, basically. So another thing is persistence. So how the malware will stay in a system after it's been rebooted, right? So normally it's through your registry keys. It tries to give these markers somewhere for it to for it to refire whenever the system comes back up. Commonly adding itself to the services also is one common thing I've noticed a lot, and also adding itself to these scheduled tasks which are there part of your system, right? So your system has these recurring scheduled tasks, and it'll insert itself as a task, as a malware will, and then whenever the system reboots back up, because sometimes what your common I would say reaction to if you find something bad on your system is like plug it out, take it off from the network and so forth, plug it off, So these there are some fail safes already built. If a malware has executed successfully, it has already done that. It's made a registry entry, maybe injected itself to your services, your scheduled tasks, and basically it adds persistence to the malware, and then it can keep on coming back again and again and again. And this is also a feature which you would want to categorize or to classify for a particular behavior for a particular malware, right? So that way, as a researcher, you know that, okay, this malware's behavior is that it is going in there, it is basically scheduling, it always goes and schedules a new task or attaches itself to already scheduled system task or something like that, right? Okay. Now, I'll go a little bit more into the events of malicious these malicious softwares. So these are the malicious events which usually you should know about. If you look at the slide, so first is the desktop locked, then there's multiple file overwrite, and then we have dumping hashes. So what are these? Let me just walk through them quickly. So desktop locked, it's very common when it comes to ransomware or some people are, what they do is they do a ransom lock, and this is basically they lock your desktop until you pay them something. So this is oftenly known as ransom lock. We know that we hear it in news a lot these days that hey, a whole company was shut down, their desktops were locked, and somebody's demanding for, and they are part of attack, which is a ransomware attack, but This attack is also called ransom lock, right? Where everything is locked down until they pay something in bitcoins, currency, or whatever their transaction is. But we have different classes, which tell you and which prepare your staff different levels on how to react to ransomware, to phishing attacks, and so forth. I would say, you go and look at it, but I don't cover that in this course. All right. So next is malicious events. You should know like multiple files. Basically, they overwrite each other, right? So this might be like file infector that normally is going to scan your whole system and then overwrite your system binaries, or any other documents in your documents folder with some malicious code, and basically it buries itself somehow somewhere and it starts overwriting. So it does multiple file overwriting, right? And this is called the file infector for the binaries. And another one is dumping hashes. So dumping hashes from memory is interesting, and it's a malicious event for sure. There might be a malicious event that is just trying to get to your say your SAM database. And SAM database, as if you don't know, it is the internal database in Windows which holds all your credentials and so forth. Like your username, passwords, and all. So dumping hashes from memory uses that technique to go in and basically infect your system. All right. So next is I think so. Previously we talked about a different strategy also about passive DNS. So passive DNS, what that is? Let me get you familiar with that. So passive DNS, I'm going to go and give you a little bit more details in the later on courses also. But I know there are some examples which I would want you to also get familiar with, right? But just for the sake of this class, since I'm just giving you an overview, let's say that you have your DNS pointing to a specific IP address, right? And so you know that, okay, if I enter this domain name, the DNS server will is being served from this IP address, right? So passive DNS or the DNSDB queries are used in your passive DNS, right? And it's always querying by your DNSDB, right? And it gets that passive value. So you can know you can basically go in your DNSDB and you can know a history of a DNS, that what are the different IP addresses this particular DNS has been associated with over a period of time, and this helps you to build out a proper crime scene or map out a malicious domain name, or to confirm if this is malicious website or not. Also, in the opposite side, you can come to know what IP have been pointing toward DNS names. So you can see like in what domains and different IPs have mapped or changed over a period of time. It is good to keep this history, and DNSDB does a good job for this, right? Okay. All right. So now we have come to the end of class 4, that is the behavior extraction. I hope you had as much fun as I did. I think these techniques are really cool and really nice to know as a researcher. And further on, when you're classifying your malicious, software which you're researching on, you can use these techniques in your work environment or as a consultant. All right. Thank you for joining. And next we'll be talking about clustering and the correlation technique. All right. Bye. Hi, welcome back. We have gone through different phases, and this class I will be going over clustering and correlation. We are in the cyber threat intelligence phases overview course, and again we already went through behavioral integration in the last one. Okay, so all the different techniques which I'm talking to you about are very, I would say, crucial when you are trying to extract information. So we started with different levels, right? We started with right from getting to know your malware, then identifying it, like different features of it, then understanding the behavior of it, right? So what is the behavior? Now, in this class, we're going to talk about the different clustering and correlation of your malware. That how do you further divide it into clusters and so forth, right? So to start with, let's look at the main goal behind clustering and correlation, right? So clustering and correlation is basically, it is used to classify malware based on its different features and its different behaviors, right? And basically what we do is we classify it and then we extract it and correlate the information to either already existing data or your own research and understand the attack flow of that particular malware, right? So it is a technique to understand the full picture of the attack flow and the attack vector and different attack vectors which that particular malware would have, right? So let's understand clustering and correlation a little bit more, right? A little bit more details around it. So basically clustering is referred to as nodes, right? And nodes are specific objects with a specific feature set and a specific behavior. So you have your node which has got a specific feature set and a specific behavior, and that is how the node is basically classified. So collectively, those different objects, when they are created, then cluster is formed, which basically has different features associated with it, right? So some of the common features for clustering nodes are timestamp, you have MPash, SSDeep, you have digital certifications. All of these different features, they are part of your particular node and how a node or a cluster is being classified, right? Many of them are static features, right? And they can help us basically classify a particular malware, and they're really important and very vital to you as a threat intelligence researcher also. All right. So another thing we have after you do your clustering nodes, you have properties, right? And all of the behaviors that we detected earlier, as you remember, like your keylogger, your downloader, dropper. We were talking about that in the earlier classes also. So those are the properties for a specific node, but this will help us also, as I said, to segregate, like based on these behavioral properties which we did in the earlier class. So now you know, okay, what are the different properties? So this helps you segregate basically into different groups. So we have all these different nodes, groups, which basically has its own specific features and behaviors, right? But also, if say it's a downloader or a backdoor, that can also help us add more context into a specific group, or even further classify it into its own micro clusters or something like that. All right. So this gives a good understanding, like how properties are, how important they are, and how clustering nodes is, and how they kind of flow when it comes down to malware, right? Next is basically correlation. So once you have information, we need to exploit it. Like how do you get that? Like can this be done by using different techniques, right? So a lot of the time correlation is done using GraphDB, right? Basically, you want GraphDB, if you don't know, it is like a relational database, but it's based on NoSQL. And it lets you basically connect all the dots, and it has a structure or a design, but not relational, like you see in your traditional RDBMS. So GraphDB is a NoSQL database, right? And it is just nothing but a collection of nodes and edges, right? If you're familiar with NoSQL terminologies, that's what it is, right? Sometimes collections also are used. So let me show you basically like how a graph looks. If you look at this picture right here on the slide, it's basically, as I said, it is just a connection between your nodes, relationships, and properties, right? So those are at a very high level. So that's how a node is there, and node defines a relationship, and relationships has properties associated with it. So all of these different things that we just found out using our behavioral phase and our other hunting phases and all. So all of them, they get classified under these nodes, and these relationships are defined within the nodes, and then properties are associated with these different relationships. And GraphDB, as I said, is a very cool way to interconnect all these. As a researcher, you should know that. And then GraphDB can store all this information very neatly, and separation is there, and segregation is also built inside your NoSQL database. All right. Another example here, if you see on the chart, is basically from CrowdStrike. So this was documented behavior of a real organization crime which took place, and this crime was carried out on an organization, as I said. So also you pay some special attention to different parts of the graph, how it is structured, and you can understand as a threat researcher, mainly it is based around the correlation part. That is the final goal of it, right? So at a quick glance, you can see in the middle of this image, there is a specific identifier. So this is the identifier, which basically helps you further analyze the other portions, like how you can, these are these hexadecimal values and stuff, from which we learn that, okay, now this is the identifier, and then you can see if anything else is associated with this identifier. So when analyzing specific behaviors, you can get a specific key, and then if you drop that into a particular software program system or something, then you can connect that to other information like IP addresses, and then you understand the bigger schema of things, the bigger picture, that where the origination is happening, what strain is this, right? So it all starts from one identifier, and further you can go and dig into it and solve a real crime, I would say. All right. So this actually concludes our class on clustering and correlation. A lot of interesting things we went over, and again, try to look at the diagram again and try to see what you can make out of that, right? All right, thanks for joining. I will see you in your next class. Bye. So we are in the Cyber Threat Intelligence Phases Overview course, and this is the different phases when it comes down to threat intelligence, and this one is around threat actor attribution. All right. So if you look at this chart, we have covered close to, this is the fifth one, and we've covered like your hunting, feature extraction, behavior extraction, clustering, right? So now you have your features, you have taken out the behaviors, you have clustered it, you have seen the properties, the nodes, you have classified them. So you have all the information which you need, right? But the big question still remains, who is behind this attack? How is that person, that threat actor, right? So who is behind that attack? And that's what you want to know. The threat actor attribution helps you identify that, right? So here what we'll do is you'll have to locate the threat actor behind the malicious cluster you have identified. So for example, you need to answer these questions like where they are located, one person, a team, a group, a gang, whatever you want to classify it as, right? So that is what this particular threat actor attribution. As a threat intelligence researcher, I would highly recommend you to understand, because you have to see, you have to understand and you have to verify the threat actors, right? And this will help you do that, all right? So now let's look at the goal as we do in all of them. So the main goal for threat actor attribution is to locate the threat actor behind the malicious cluster identified. So for example, you need to answer these questions like, where it was originated from, where it is located. So all these will be answered, right? So as I said, as a researcher, you need to be ready with this answer, right? And the question first begins is, where are they located? Which continent, which country they are located in? Next important attribute you would need to be aware of is who is sponsoring them. Usually, you'll be surprised 99% of the time they are sponsored. Sometimes an attack can be sponsored, say, by a nation state. For example, it could be a Russian government or like Chinese government or any other government sponsoring a malware or a malicious attack. Then we see there's a lot of these in the recent, you read in your newspapers, 2016 was full with that. 2017 already talks are going on that a lot of nation state sponsored attacks are being carried out. So Chinese government, like it could be like so any government, Nigerian government, it could be anything. So that way there's a lot of these attacks which are being done, and similar attacks known to also to be launched by US also. So USA also sponsors a lot of these attacks, and this is as I had mentioned before also, it is cyber war going on, right? And this is the next level of warfare, and you don't even need to fire a single bullet. You can still take down a whole country. So what sector and industry are these people targeting? So normally the groups are going to focus on a specific sector, right? There's always a reason, a goal behind a particular attack when it gets launched, and it's always aimed at a particular sector. It could be the financial institutions such as banks, or probably they're just trying to focus on, say, a nuclear plant, taking the nuclear plant offline, or trying to damage the nuclear plant, as you saw. It happened last in 2016 in that year. And also help you to categorize, that who are these threat actors. So this will give you good information when you see, like, what industry, what sector they're focusing on, right? And there's the C2 infrastructure, right? The command and control infrastructure. Those who are new, as I said, it's command and control. It's also known as CNC. Command and control is that where they are located, and this is where once they get access to a particular system or to a particular network, this is from where they launch the commands, or where the information goes to, or from where they like either a remote desktop in or terminal server in and get into the different ports. So we come to know what are different ports being open, what is the operating system they are running, are those details around them, and so these kind of help us understand the C2 infrastructure also in some cases, because you cannot backtrack them, because they always wipe out their tracks, but then the kind of behaviors which they launch, or the kind of things which they do in a contained environment or in their command and control C2 infrastructure, this is how you specify that also, right? Another thing is your tactics, techniques, and procedures, which you should know. Also, the tactics, techniques, and procedures are commonly referred to as your TTPs. All right. So TTPs, as a threat intelligence researcher, you will always be dealing with TTPs, which means that how do they get into the system? What are the tactics, techniques, and procedures for getting into or infiltrating into a system, right? So the techniques being used here, mostly what the bad guys do is they have different procedures and different skill sets which they use, and which is basically to help you identify and define a specific group, right? And here probably you might need to need like somebody like a reverser or a reverse engineer who can also help you identify those different tactics and techniques which a particular bad guy or a hacker is using, and which you are looking at, right? What are different algorithms, encryption algorithms they are using, right? How are they decoding the binaries, and where are they being decoding in the memory? For example, where is the malicious code injection happening? It is in the memory, or is coming from a result of a binary, all that details, you can get out, right? And also another thing is how you get persistence into a system. And I mentioned that earlier also. You can get persistence through your registry keys. You can launch some tasks, system tasks. You can do services, COM object hijacking. There are different techniques, in which you can basically gain persistence, right? So these techniques, those with the help of a reverse engineer, they can also help you to understand these threats and better, basically. All right. So another thing is that when you are being initially compromised, how do these bad guys get into the system? Can they did they get in through a spear phishing attack, or it can be just through like a Facebook link which they shared and fool you to download a malware, right? You just thought, oh, this is a message from a friend or from a group or something, and you just clicked on it, and now boom, there's malware being downloaded. So all these are different, spear phishing techniques, so social engineering techniques that basically also define that specific group of threat actors. Also, privilege escalation. So when there's an escalation in privileges, this is basically when somebody's entered your network and they're trying different techniques around it. They're trying to like escalate privileges of a user, make it a sysadmin, and so forth, right? And either use sudo or some other accounts, right? So some other TTPs are persistence and lateral movement. So if they are how persistently they're there, and if they're moving laterally within the network, they're penetrating deep or not. Very important is how do they spread inside a network. So different groups use different techniques, and it is very important to define and specify those groups. So once you spend more time doing this classification and reading, the behavior, how the entry points, how they're entering into a particular network, how they're hiding themselves, how they're building persistence, how they're even moving inside, how they're doing privilege escalation, you will slowly try to understand, get in the shoes of the hacker. As a threat intelligence researcher, now things will start becoming fun to you, because now you know that this is how the bad guy is thinking, or this is the behavior which you do, and now they fall into this group. In that group, it could be hundreds of them, but then you know exactly which group it is, because now you have identified them. You have segregated, classified, clustered. You put it in the right nodes, given them the right properties, right? So last one I want to go over is the exfiltration strategy. So how do they steal the information, right? So now that's the very important thing. Everybody has their own technique, right? As they upload some files, it's by they're using specific HTTP protocol requests, or either it's via a raw socket, even they're using certain proxies in a certain way in different countries. So how they are doing this, right? What information they're extracting, what is the format of the information which is being extracted. So this is all part of their exfiltration strategy, right? And all this helps you understand the basically the property, and help you classify and identify and catalog this behavior of a particular malicious group or a particular malicious threat actor. All right. So this is an important note. So key takeaway, and I'll say from these particular last few slides is, if no threat actor can be identified, the whole threat intelligence effort is useless. That's what I say. And at the end of the day, you have found the malware, you can do your features, you can do behavior, you can do clustering, but if you don't know who is behind the attack, you cannot take down that organized crime or that organized crime branch. All right, thanks for joining, and I'll see you in the next class. We'll be talking about another aspect, that is tracking. All right, bye. Welcome back to Cyber Threat Intelligence Phases Overview course. We are going to talk about tracking today. So now, as a threat intelligence researcher, you have gone in and done the hunting, you have gone in and done the feature collection, you have done behavioral organization, you have done node classification. So now there's more to do, because now you also identified the threat actor, right? So the goal is, as I said, is to anticipate the new attacks and identify new variants proactively, right? And that is one of the main things which we will talk about in this class. So what is the goal of tracking? The goal is to anticipate new attacks and identify new variants proactively. So next, let me tell you how you can understand and meet this goal, right? Because you have to understand it and how you would do it proactively, right? So we have always been talking about different mindset earlier in this course also. All right, so in tracking itself, I want you to get familiar with certain techniques, All right, the first one is DNS, passive DNS actually. So what happens is that attackers can switch from a new domain or point to a domain with a new IP address. All this can be mined out by querying the passive DNS database. So by querying this, you simply, for example, if somebody has pointed their domain to a new IP, or they're frequently changing to new IPs, so you can mine all that data from passive DNS database. All right. Another technique is internet port scan. So that's a risky but very interesting approach. So basically, if you know that your C2, the command and control, is listening into a specific port or different ports, you can go and scan the internet and find those C2 infrastructures. So basically, you're going up a little bit. You're going into their world. You do expose something, and that's why I said it's a little risky, right? So next up is lookups. So you have the features, you have the behavior. You can create a Yara rule or even snot rules to try and hunt through all this through VirusTotal, or go into your own database in your company with hundreds and thousands of samples and try to search for those features. So basically, it's basically lookups, right? So VirusTotal is a nice lookup engine. And so use VirusTotal service. You can put in your Yara rules saying that, if they're matching a particular string, a particular API, byte, anything, email address, and once you put in your Yara rules, you can also tell in VirusTotal that, hey, whenever a match is, you find a match, you basically send me an email so I know, I get, informed, right? Other things you should be familiar with is your imp hash, SSD hash is very important here also. As you remember, imp hash and SSD hash properties, they also help in defining similarities between samples, and then you can use it to further track and find those some other samples just similar to that, right? Next is your open source intelligence, which is called your OSINT. And so with this information, this is all open source, available on your search engines and stuff. You can go and check for IP addresses of the command and control center, and also probably you can find the email addresses associated with your new domains created with the different sets of information, right? So that is the power of open source intelligence. Again, I want to recommend this one, that is the gang infiltration into hacking forums. Obviously, you can keep tracking them, and still like, hacking forums, they discuss, they talk about a lot of, stuff, the new releases of the tool and so forth. So if you're watching them, you can get all this information, and I would highly recommend that you strictly just observe, watch, don't participate, and don't go too much deep into it. Don't commit anything, to these forums or hacking or gang infiltrations, right? But this normally is done with the help of some law and order, like say FBI. So, and also they have like some secret agents also in there, so you don't know who you're talking to, and you want to just act as if you're a hacker, and now on the other side is FBI agent, you could go in jail also, just to let you know. So be very careful. All right. All right. So this concludes our tracking class, and the last step we're going to discuss in the next class, that is taking down. Again, keep things in mind. Don't go overboard when you're looking into when you're trying to track or trying to get into some certain malicious software. Always remember your boundaries as a threat researcher. All right, and keep law enforcement on your side. Well, thanks for joining, and I'll explain more in our takedown class that how you get the bad guys, how you track them down, and how you've tracked them, but how do you get them to jail or to dismantle their operation. Thank you. Hi buddy, welcome back. This is the Cyber Threat Intelligence certification, and we're talking about different phases, the overview phases. So this is the last phase, and this phase is called taking down. All right. So taking down is a critical technique for you all to understand, and this is also a final step. So far we have understood everything about the group, about, we know, like, what is the ATP group. Say there is a group called OWL network or Cyber OWL, right? So you'd give a name to that group. That group always has identification. As a researcher, you're also tracking them, and probably it's time for you to take them down. So in order to take down a group, it has to be a joint effort between your team and the local law enforcement. Mind you, again, the local law enforcement. So if you are trying to take down a group which is not in the legal jurisdictions of your country, you have to work with that local law enforcement. Usually, like, some law enforcement bodies which are very common are Europol, Interpol, FBI, depends on the country, right? But you should always work with them, and it has to be a very joint and a fully functional, collaborated effort, all right? So first, let's look at the goal, right? As I said, the goal here is to fully dismantle organized crime operations. Your goal is, as a researcher, you want to first, you've done your work, you've done the research, you've identified. Now you want to dismantle them so they cannot do further no harm to your organization, to your clients, or to any other similar organizations, right? So taking down the bad guys, basically it's physically getting them arrested or stopping their operation, right? So what are some of the different techniques when it comes down to taking them down? So let me get you familiar with that first, right? So one of the really cool one which I like is called sinkhole. So sinkhole, as we are going to talk about that in detail. At a very high level, this technique basically involves you to taking over the C2 infrastructure, the command and control infrastructure, by using different approaches that we are going to go over, that we went over earlier also. And then what you do is that everything, all the different hosts, the infected hosts are going to all point to you now, right? So, and they're not going to point to the bad guys, and the traffic is now directed to your server. So you're kind of intercepted, and now you are kind of behaving as a sinkhole. You're taking over the C2 infrastructure, right? And what this does is, this approach we're going to also tell you a little bit detail on it, but at the end of the day, your simple goal is just stopping the operation. That is what you are focusing on, right? Also, you can do like a man-in-the-middle attack, which basically means that I will forward all the traffic to my box, and then forward it to the bad guy. So you are kind of siphoning or kind of checking everything. It's going siphoning through you, basically, right? And so this is the man in the middle. So you think, so bad guy thinks that they are still operating, so and you are monitoring what they're operating on, what kind of information it's going back and forth on the pipe, and you are in there, and you're monitoring everything, all the actions, right? And from a single point. And we don't let the victims get reinfected. That's also one thing, that we stop anything which is a red flag to us, right? All right. Another thing is another tracking, taking down technique you should know is hacking forums. So hacking forums is a very common way to take them down. And there, for example, there was a hacking forum called Dark Code, right? You must have heard the Dark Code case. If not, then it is basically a hacking forum. It was a specific forum which was very famous for selling and discussing about exploits, all the exploits for operating system and so forth. And that was the Dark Code hacking forums, right? So it was taken down, and one of the most common law enforcement things that what they do is they shut it down. They permanently shut it down. They take the owners, and when the takedowns, basically what happens is, as I said, always in takedowns, you need to have full support and collaboration, right, of your local country law enforcement, and has to be a well collaborated countrywide or continent-wide or nation-wide effort, right? Let's say if there is an IP detected which has been attacking from China. So it's not easy to ask China, hey guys, Could you please go into this internet service provider or the ISP which is hosting this IP and take this down, please. That's not going to happen. Same as with other Russia, where USA is also launching similar attacks. So there are some things which you should know as a researcher will not happen, so don't try to go that route. Maybe you will dig a hole for yourself, right? So finally, let's talk about the summary of this class. We have gone through all the different techniques. You understood how taking down works also. So we started with different phases of threat intelligence, the efforts which I kind of went over. We went over like the big picture, really some cool techniques and skills we talked about, and finally the goal of that is basically tracking down and taking down the threat actors, right? While we were doing this, we also, I told you, like, behaviors are very important. Basically, segregation is very important, and also then consolidating all of that into nodes using GraphDB. So all of these different techniques, right? And in the end, everything leads down to if you are fully accessible, and if they are in a jurisdiction which your FBI, Interpol, or Europol has and can get you in and stop their effort. The end goal is basically go in there and stop the bad guys, right? Usually some of the bad guys, they also operate from different IP addresses, different servers. But the good part is if you know the physical address and if you know which country they're originating from, and if you've done your research in a very I would say well-mannered fashion, then now you know the address, the IP addresses, their C2s, which different ISPs they're coming from. So you've gone and looked into their C2 infrastructure. So you've also gone in and filtered their traffic through your particular infrastructure. So now the bad guys, you know where they are, you can take them down, and this always is a collaborated effort. And you can go through Interpol, Europol, local FBI, local law enforcement. All right. So hope you enjoyed this this course about threat intelligence, and thanks for joining. I will see you in the next course and get into more details around all these different techniques. Bye.